Curriculum
Apa?
yang
Belum. Aduh, kalah. Harus. Pak Sarle orang. Live.
Really not bad. It's a very big money.
Augas lama enak kita apa yang semua nih.
You need to be really quiet while they are solving problems.
Udah bro. Ikut. Karena peradaban. Filipina.
jadi anak iki aku ana lombane di lomba none. Aja datang.
Karena peradaban. Karena peradaban bukan perlawanan.
Ya iyalah saya nggak ngerti jawabannya nih. Sekiranya.
Iya, semua menang juara. Oh, hujan memang.
Apa ngerjain soalnya?
Betul mana betul.
Many other prayers. Le, minggir dulu. Mari. Cepet ya. Iki dipilih 4 yang terbaik iki.
Segment ทำให้ set of consecutive notice
Ini mundur.
Rabat. Terus apa? Oh, ini kan orang doang. Masih banyak banget sih. Berapa? Mak itu tiga.
Ini jawabannya papat. Wih. Jawabannya papat.
ลงมาแล้ว
Loro sing bener.
Mana?
Loro sing bener iki lho.
Enggak ada.
Ya, iya, 4 kan jawabannya.
Kok nggak sembuh? Benar atau salah?
Sing bener jek nang ngarep. Waduh, kesana wis 4 besar. Ini baru pemilihan ini. Aja dipilih-pilih sing bener-bener iso. Itu ada 2 anak di depan itu. benar-benar itu dipilih dari 4 anak tadi. Dari banyaknya peserta dipilih 4, habis itu dipilih lagi 2. Nah ini jadi penentuan juaranya. Dan
Okay, we have to be quiet while there's the problems.
oh iki sing iya, ndek ini sing soal soal apa? Soal iki apa? Tim ini yang tim ya? Yang tim pertama. Soal pertama. Iki apa peluang ya? Iki peluang nih.
Peluang kasih. Oh, belum.
Iya peluang.
Dan sen.
Kamu bener junior. Aduh.
Mau bilang akan dengan
Usmari. Sekali biar. Banter ya. Karena soalnya ada yang ingin loh. Itu junior ya Isa.
ini aku kemarin
Ada jangan belajar ki wis melampaui. Tiga 9.
Sembilan.
Okay, now we're going with the tiebreakers. Again, okay, well done tiebreakers. And now before we actually start off the award ceremony, we have a special lecture from Dr. Incheon.
sing gawe matematika nang
Okay,
ChatGPT.
everybody, please have a round of applause for Dr. James J.
ChatGPT. Oh, Riz. Sing biasanya mbok gawe, Riz. Kita gasisan.
So as I was going to this talk here, I asked Mr. Yu, is there anything I want me to focus on? And he said, please make it short. So I made a recording of it, and you can watch it. Hello everybody, my name is Incheon and I'd like to talk about math in the age of ChatGPT. Before I start, I'd like to make it clear that although I'm one of the certified instructor of Mathematica, I didn't get paid to give this talk. Everything I say here is all my thoughts, and I pay for my own license of Mathematica that I use.
Na Jakarta.
Once I heard a wise saying, it goes, you cannot win a race against a horse by running, no matter how fast. Instead, to win, you have to ride it. We have been living under the influence of AI for over a decade. These days, we routinely say, there's an app for that, for whatever problem we need to solve. Little we realize these apps make us dumber, while making the app makers richer. For example, many of us cannot read maps anymore. More seriously, AI has been controlling us by deciding what we read. When I look for a book on Amazon, at the bottom of it, it recommends these books. If you ever clicked on this, Amazon controls what you read. And it controls what we watch. If you search for anything in YouTube, you see these recommendations. If you clicked on any of them, YouTube controls what you watch next. And what's more, AI has been getting smarter. In 2016 March, AI defeated human in the game of Go. This was not supposed to happen in my lifetime, perhaps even in your lifetime. And recently, ChatGPT started solving competition math problems. I gave this 2023 EMC8 problem to it. This is hard. It involves folding and cutting and guessing or predicting what kind of shape you will get. And guess what? It solved correctly with correct reasoning. So what do? Nobody knows. Even inventors of ChatGPT doesn't know how this is going to unfold. One thing is clear, we cannot just sit and take it. We cannot just let machine decide what we watch, what we read, what we think, what we buy. We have to take control somehow. We have to start riding the horse, controlling the machine. Although we do not know where we are going to end up, it will be a whole lot better riding there than being dragged there. All right, so where and how do we start? To control the machine, you need to understand, first, how they think, and two, how they speak. That is, you need to understand their language. Only then you can make it do what you want. Speaking computer's language is called coding or programming. Many middle and high schools in the world started teaching coding recently, but they all treat this coding as a separate subject from mathematics. I do not agree with that, but I understand it because many students have difficulties with math alone. There are many computer languages in the world. However, Mathematica starts from mathematics and expands to the world. So this would be the quickest and easiest way for you to learn computer language. Let me do a quick demo to show you what I mean. By the way, this presentation is in Mathematica itself. You can do all the computations, but look how mathematics it looks. You don't have to write special codes for that. And if you ask it how to solve quadratic equations, it tells you the answer in the familiar mathematics form. And Mathematica is a symbolic language. You don't have to go from certain number to certain number, as I showed you before. You can go to n, and it will find it. And you can get nasty, such as squared. Did you learn this? Look at that. And you can get nastier, like this. And right there is an interesting Question for you. No matter what n is, if you plug in, it will be divisible by 42. Really? How can you guarantee that this number is divisible by 42? Another powerful feature of Mathematica is this manipulate. Here is this good old first degree linear equation here, mx plus b. What m does and what b does can be learned clearly by controlling what m is, here's the value of it, and what b does. So therefore, you students can learn the exact role of b as well as m. Notice how little it took to write this here. Students, rather than just watching math as a spectator sport, you should create these things yourself, because then it gives you deep understanding of the problem. And also, functions are functions. So if you replace this function with another function, let me go down and show you. I replaced it with a quadratic. And now I'm controlling A, B, and C of quadratic equations. And I'm just assigning the initial value for these, A, B, and C. And then what happens? I can control A, I can control B, and I can control C. So you know exactly what each parameter does to the function. First degree equations have slope-intercept form and also point-slope form. The power of point-slope form becomes clear once you write it this way. So for example, I can move it to the right and up. Then I can control the slope. So imagine assigning to students to create this animation. Decide where the center point is and let the slope flip around at that point. Students are forced to discover and understand the point-slope form automatically. And as I said, this is just a function. You can plug in any other function here. And this time I use the quadratic function here. So you can explain, as a teacher, you can explain to students, this shifting of the graph, also known as translation, works in any function. Just mess with x and mess with y at the end here. And then you will get this shifting behavior. So I have this here, and I can move the graph to the right and up. See, I couldn't do this with ax squared plus bx plus c. So assign this kind of homework to students, and they are forced to discover this kind of presentation. Now let's see how powerful teaching of systems of equations can be. Instead of having just one equation, now I have two. So I have to group it with a curly bracket here. I got two. And I have now 4 parameters. I'm controlling them separately. And what happens? I am controlling them separately. So this is for the first time. Right? And this is for the second time. Now imagine this powerful homework. Plot a blue dot at the cross-section of these two lines. See, there's a blue dot. For the students to do this here, they have to understand the systems of equations completely. Now about calculus, tangent to a point can be explained by having students make this. And this can be turned into any other function. For example, I can make it x squared. And then I have the same thing again. When I was studying multivariable calculus, I had to use my imagination. Now students don't have to. They can actually see it by moving this to different locations, what the gradient looks like. And you can change the function and go to different spots and see the gradient visually. One of the hardest things to conceptualize is iteration. Now, with this here, you can actually see it. This is Newton's method. You can decide on where you want to have initial guess. And then the first iteration would be this. Thank you. I have slightly good news. I have secured the sponsorship of Wolfram so that I can provide a license for all the copies that came with this. And our organizer, Mr. Yu, decided which students will get it. But as I showed you, you can do it for free on the Wolfram Alpha, from Cloud site. The trading account using it the way I showed you is free. You can all do it. But the important thing is, overall, the ChatGPT will teach you how to use this. You can just ask questions. Why, how, and it will tell you. But I also would like to copy what I'm doing in Korea already. That is teaching the demand. So if any of you are interested in offering this type of course to your students, please let me know. Thank you.
Now that was employing. I can't wait to go studying or work like mathematical writing. Okay, now before we continue on, I'd like to introduce this year's post-country organizer, Patrick Yu.
Okay, thank you for coming. Welcome back. 2016 and 2019 and 2023, right? I hope you guys have a really good experience while you stay in Korea. And I would like to share the short information with kids, teenagers. I have been running some kinds of individual competition or team-based competition almost 20 years, believe it or not. And I have been running nationwide this time. Luckily, I had a lot of chance to meet good students, and they have been studying at Harvard, MIT, Stanford, Yale, Columbia, Oxford, Cambridge, everywhere. I have been wondering how they got a good achievement, almost the same